Section 10.6 is on secants, tangents, and angle measures. A secant is a line that intersects a circle in exactly 2 points. So line, in this diagram here, line AB is a secant. A secant is always a line that continues forever in both directions. However, AB is a chord. So you could say that a secant is a line that contains a chord of the circle. A secant is a line, a chord is a segment. Here's a theorem. If two secants, or two chords, intersect inside a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. That's an incredibly wordy theorem. Let's take a look at it and see what's really going on here. Let's look at angle 1 here. So what they're saying is the measure of angle 1 is equal to 1/2 of this arc plus this arc. And as you can see, angle 1 intercepts arc AD, and the angle that's vertical to angle 1 intercepts arc BC. So the measure of angle 1 is going to be 1/2 of this arc plus this arc. Similarly with angle 2, let's take a look at angle 2. So angle 2 up here, doing purple, the measure of that is going to be 1/2 of arc AB plus arc CD. And notice AB is the arc that angle 2 intercepts, and arc CD is the arc that the angle vertical to 2 intercepts. Let's look at some examples that involve this. So in each case here, find x. So here we have two chords that intersect inside the circle. This arc out here is 76 degrees. This arc over here is 88 degrees. So the measure of that angle is going to be 1/2 of the arc that it intercepts, which is 67, plus the arc that its vertical angle intercepts, which is 88. And doing that in the calculator, I get that that is 82 degrees. So the measure of angle x is 82 degrees. Example number 2, here we have a 60-degree angle, and that intercepts an arc that is x degrees, and its vertical angle intercepts an arc that is 25 degrees. So the angle, in this case 60, is equal to 1/2 of the two arcs added together, x plus 25. Now the easiest way to solve this is, I don't really want to distribute that 1/2 and deal with fractions. I'm going to divide both sides by 2. So that means that this and this will cancel. Don't distribute anything into the parentheses. So I have 120 equals x plus 25, or the measure of that arc, x is 95. Here's another theorem. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. This is another wordy theorem. Let's unpack this one. So the measure of angle DAB, so this angle right here, is going to be 1/2 of the arc that it intercepts. So this arc right here, arc AB. The other angle that's created, angle BAC, that's this obtuse angle, is going to be 1/2 the measure of arc BEA, going around this way. So the measure of the angle is going to be 1/2 of the arc that it intercepts. Let's take a look at an example. Find the measure of angle ABC if arc BDC is 250. So I know that this arc over here is 250 degrees, but what I really need to know is what the other arc is. What's the measure of arc BC? Well, the measure of arc BC, okay, is going to be 360, because that's the distance all the way around, minus arc BDC, which is 250, or 110. So this arc over here, arc BC, is 110. So the measure of angle ABC is going to be 1/2 of that. So the measure of angle ABC is going to be 1/2 of the measure of arc BC, or 1/2 of 110, which is 55. Okay, this next theorem is actually 3 theorems in one. I kind of combined them all into one because they were all kind of saying the same thing, but with different pictures. So, if 2 secants, or if a secant and a tangent, or if 2 tangents intersect outside the circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Another incredibly wordy theorem. Let's take a look at some pictures here. So here we have the measure of angle A. Oh, in this first picture we have 2 secants that intersect outside the circle at point A. So this angle formed, which is angle A, is going to be 1/2 the measure of arc DE. I'll go ahead and outline that. Minus the measure of arc BC. So to find the angle, it's 1/2 of the big arc on the outside minus the little arc on the inside. And if you always do big arc minus little arc, you're always going to end up with a positive number. Second diagram, we have a secant line, which is AD, and we have a tangent, which is AC. And again, they meet outside the circle. So the measure of angle A is 1/2 of the measure of arc DC minus the measure of arc BC. And again, since it's like the first one, which was 2 secants, this one's a secant and a tangent, the measure of the angle is equal to 1/2 of the big arc on the outside minus the little arc on the inside. In our third example here, we have 2 tangent lines that meet outside the circle. So the measure of this angle A is going to be 1/2 of the big arc on the outside minus the little arc on the inside. So you're doing basically the same thing for all 3 of these diagrams, whether it's 2 secants, a secant and a tangent, or 2 tangents. The angle is 1/2 of the big arc on the outside minus the little arc on the inside. So let's do some examples that use that. Here we have 2 secants that intersect outside the circle at angle 1. So the measure of angle 1 is going to equal 1/2 of the big arc on the outside, which is 88, minus the little arc on the inside, which is 26, or doing that on the calculator gives me 31. So the measure of angle 1 is 31. Here's another example. Here we have a secant, which is AD, and a tangent, which is AB, and we're going to use the same theorem. The measure of angle, we need to find the measure of arc BED. And in this case, we're given the measure of the angle. So the measure of the angle, which is 71, is equal to 1/2 of the measure of the big arc on the outside, and I think I'm going to call that X just to make it a little bit easier. The big arc on the outside minus the little arc on the inside. And again, I'm going to multiply both sides by 2 to get rid of that 1/2. So that's going to give me 142 is equal to X minus 106, or adding 106 to both sides, X, or the measure of arc BED is equal to 248. And our last example here is 2 tangents that meet outside the circle, and I need to find the measure of angle A. And unfortunately, there's only one number in this problem. All I know is the smaller arc on the inside, which is 140 degrees. What I really need to know is what's the measure of arc BDC. I need to know this one out here. Well, the measure of arc BDC is going to be 360, which is all the way around the circle, minus 140, or the measure of that arc is going to be 220. So using the fact that BC is one part of the circle and arc BCD is the other part of the circle, and together they make 360, I can subtract to get the big arc on the outside. Now, the measure of the angle is equal to 1/2 of the big arc on the outside minus the little arc on the inside, or 1/2 of 80, or the measure of angle A is 40. So in this section, we were introduced to the idea of a secant line, and we had many theorems on secants, tangents, and what they do. And these theorems here, basically one theorem with 3 different cases to it. If a secant and a tangent intersect at the point of tangency, and if 2 tangents intersect inside the circle. The key to this lesson is going to be looking at the picture that you're given and trying to figure out which of these theorems you need to use.